हो जाएंगे अभी. Tell you some tricks. Can solve it in a.
आज सर मैंने क्या कहते हैं वो डायनेमिक्स करी थी नीट के
Okay.
क्वेश्चंस.
Okay. Nice.
मैंने शायद आपको भेज भी दिए हैं.
Okay.
आ, मैंने पीएनसी की असाइनमेंट भेजी थी, आपने चेक करी क्या?
दो मिल तो गई थी.
हाँ जी, चेक कर ली.
असाइनमेंट एज इन.
वो मतलब जो मैंने कल सॉल्व करके भेजी थी.
अच्छा, नहीं नहीं, ये कौन सी वाली है जो मैंने भेजा था?
और जो हाँ वो वाली सम बेसिक कंसेप्ट ऑफ केमिस्ट्री और परमुटेशन कॉम्बिनेशन.
ओके. आई विल सेट अप अ क्लास विद यू टू आइडेंटिफाई योर डिफिकल्टीज इन इट.
ठीक.
कि कौन कौन से क्वेश्चन यू फाउंड देम टू बी सो.
सर मोस्टली तो काफी क्वेश्चंस थे.
हाँ, मुझे पता है.
अ, मतलब स्कूल लेवल से भी मैं कहूँगा थोड़ा सा कम थे.
ओके.
ये एम जो हमें स्कूल से पहुंच रहे हैं वो तो ज्यादा ही थोड़ी ट्रिकी सी थी.
थी. अग्रीड. Okay, so we did the disk. Okay, so the disk was, we took a ring inside it, and this ring was of thickness dx and radius x. तो ये x की थी और thickness इसकी dx थी, right? ये वाली, this part. ऊपर से देखने पे it looks like this. So this is your disk, and you carve out a ring out of it, which looks like this from the top. So this is your ring. Okay, and you calculated its area, uh, pi x plus dx square minus pi x square. This is the area of the ring taken from the disk, and then we took the whole
dx
disk,
what is dx?
the width of the ring. ये last time I'm just recalling, helping you recall
अच्छा
कि
अच्छा.
हमने क्या करा था.
अच्छा
The,
ये इसको कह रहे हो आप?
हाँ, ये जो मैं just highlighting
हाँ.
this
ठीक.
area, ये
ये
रिंग
स्मॉल
का
वाला
एरिया.
स्मॉल
यस.
एरिया.
हाँ जी, स्मॉल एरिया. ये करा था हमने लास्ट टाइम, और इसकी जो डेंसिटी थी दैट वाज मास अपॉन पाई आर स्क्वायर. मास डेंसिटी ऑफ द डिस्क पर यूनिट एरिया. ओके,
ये
सो दिस इज पर
लैमिनाइट
यूनिट
करेंगे.
एरिया. हाँ. यस. परपेंडिकुलर एक्सिस है यहाँ पे. तो फिर हमने इसका निकाला था, द मोमेंट ऑफ इनर्शिया डी आई is equal to m, the mass of the ring, multiply with its distance from the axis. ये axis है. So this is your x. So the mass will be m by pi r square per unit area, and the actual area available of the ring is available to you and into the x square. This is the total moment of inertia of the ring, and then we open the bracket m by pi r square pi. We did this in the last class. I'm just revising it to x delta x minus pi x square into x opens up and gets cancelled. Okay.
सर आपकी आवाज थोड़ी.
हाँ, नहीं वो हिल गया था इसलिए. अच्छा, now it's fine. So m upon pi r square. So dx square approximately becomes 0, and pi x square will get cancelled, and you will be left with x raised to power 3.
सर क्या लिखा है आपकी राइटिंग? क्या है ये?
Pi, this is
पाई है.
yeah, this is pi.
दिस इज पाई. व्हाट इज दिस? इज एक्स.
This is x plus d,
क्या लग रहा
a
था ये?
plus b, a plus b whole square. This is a square, b square, and this is, I think I'll just bring it closer.
Okay.
So this is 2ab
ठीक.
minus pi x square. If you open the, this is approximately equal to 0, dx whole square. So you are left with the pi multiply by 2x delta x multiply by x square. This is the moment of inertia of the ring. Tell me if you're not able to understand any step in this.
Yeah, simple.
Now you need to integrate it from 0 to r and solve
Yeah.
it, and you will get
0
m
to
r.
r.
Yes,
r अच्छा ठीक है.
ये आ जाएगा x4 by
नहीं,
4.
r4 लिख लेंगे ना.
यस, r4 आ जाएगा, इसके
r
साथ
raised
कट
power 4.
जाएगा, एक 2 भी कट जाएगा, so you'll be left with mr square by 2. This is the moment of
हमने दोनों
inertia.
साइड्स को इंटीग्रेट किया ना, di को भी.
Yeah, yes,
ठीक है.
yes, definitely.
सेम लिमिट्स के साथ. ठीक. अच्छा I to 0. ओके.
रेडियस की लिमिट है 0 to r.
ठीक.
Tell me what is not clear in this. Very
इसलिए
school level derivation type of work, you know.
यही आएगी वैसे.
ऐसे ही मतलब one of the, so now you can start applying the theorems, parallel axis theorem, perpendicular axis theorem, सारी लगना शुरू हो जाएंगी इसके ऊपर. Okay, now let's say you have to calculate the moment of inertia mi of a disk, and when you apply now about any diameter. So now, which means this is your disk. On the perpendicular axis, you have calculated I perpendicular axis. इस axis पे तो निकाल ही लिया है. Now around any diameter, which could be this, passing through the center, or it could be this. So any diameter, right? So we know if we take two diameters, so we can apply the perpendicular axis theorem. The sum of two perpendicular diameters which are in a single plane will be, so this is for example AB diameter, this is CD diameter, and this is a right angle. Then the moment of inertia around AB axis plus moment of inertia around CD axis is equal to the perpendicular to the plane. So जो हम निकाल चुके हैं is equal to mr square by 2. और क्योंकि diameter same ही है दोनों, तो these are two same, so 2I about any diameter is equal to mr square by 2, and I diameter is equal to mr square by 4 answer. So you are able to find about any diameter with the help of this knowledge. Any doubts in this? Perpendicular axis theorem. Okay. Let's talk about now third one, which is moment of inertia of a disk about any tangent. So now you keep your disk like this. Now the axis shifts by a number. So you know the moment of inertia around a diameter. ये diameter वाला निकाल लिया, तो ये axis है diameter वाला, इसका मालूम है mr square by 4 होता है, और you shift this axis by this much, okay, r. So this is mr square. So mr square plus mr square by 4. Parallel axis theorem. The axis has shifted to this side. Okay, so this is 5 by 4 mr square. So if you want to find around a tangent, then the tangent is parallel to one of the, you need this diameter. Diameter का already हमें पता था. So now we know across. So you can also fix the axis here, and the whole disk can rotate around this axis. ऐसे ये आ जाएगी ऐसे घूम के, like a coin generally, but coin तो centrally pass होता है. Coin को edge पे रोक दें और फिर घुमाना शुरू करें. So moment of inertia of a uniform disk around 3 axis we have found. Now we can find it in a axis which is parallel to the perpendicular axis. So fourth, so the same situation, now the disk is here. Now the axis is taken parallel, but parallel to the perpendicular axis, not to the diametrical axis, which is this. So this is your perpendicular axis. And you know, iska mr square by 2, we have just done a derivation. Shift the axis by an amount like this, r. So extra moment of inertia which you get is mr square. And therefore the total is mr square by 2 plus mr square is equal to 3 mr square by 2. This is the total moment of inertia about the tangent, but the tangent is parallel to the perpendicular axis. So fourth is tangent hai, but perpendicular to, sorry, parallel to the perpendicular axis. Okay, now let's move to the next one. The next very important,
डेरिवेशंस थी अभी अभी तक तो.
हाँ मतलब बेसिक्स हैं, बट दीज विल हेल्प यू डेवलप अ माइंड कि कैसे आपको सोचना है. नाउ लेट्स से यू टू फाइंड द मोमेंट ऑफ inertia of a thin rod. ठीक है, so this is your rod, for example. Okay, this is your rod. So perpendicular axis बना लेते हैं पहले. Let's make a perpendicular axis. This is the perpendicular axis, and the consider a very small mass here. Total mass of the rod is m. The length of the rod is L. So per unit length basis, the mass density is mass upon L. Take a very small length of the rod located at a distance x. तो इसका जो moment of inertia around this axis, perpendicular axis, will be given by di is equal to इसका छोटा सा mass m by L into dx is mass of the small multiply by x square. So this is the moment of inertia of the small part. Integrating both the sides again. So this will be m by L integral x square by dx. Now integrated from x. This is the origin. Varies from minus L by 2 to L by 2. Or you can do 0 to L by 2 but double it. क्योंकि दोनों साइड पे symmetrical है. So you can do minus L by 2 to L by 2 is equal to m by L x cube by 3 minus L by 2 to L by 2, and this will become equal to m by L by 2 cube into 1 by 3 minus L by 2 cube into 1 by 3 is equal to m by L. This is L cube by 6 plus L cube by 6 is equal to m by L 2L cube by 6 L square. So m L square by 3. So this result should be known to you. ठीक है, एक मिनट, have you done the right calculation? X cube by 3 L cube by 6 plus L is 3, and बाहर था m by L. So this is m by L 6 ml square by 3 into ml. So ml square by integral सही नहीं आया. L, अच्छा, okay, 2 cube is 8, sorry. Okay, so 2 cube is 8, so this will become 4 actually. L cube का 3 भी है नीचे, so 3 into 8, so this will be 2, 3 into 8, 2 4s are, so ml square by 12. So the moment of inertia of a rod, if it is rotated around this axis, is ml square by 12. ये सारे आते हैं जेई के अंदर. शेप्स याद होनी चाहिए सारी कि किसका क्या है. There is a chart available just in case you tend to forget, तो can derive it also, but याद हो तो बहुत अच्छा रहेगा. The other way you can make this rotate is this. So take a situation like this. ऐसे बनाया और fix it here. Okay, fix it here and now rotate it. So you will get the parallel shift करा actually. पहले सेंटर में था उसी के पैरेलल शिफ्ट कर दिया. Either you can apply a parallel axis theorem and calculate it. So and for example, this is ml square by 12. So what is the radius of gyration for this? So ml square by 12 is equal to mk square. mm कट गया. So k square is equal to L square by 12. K is equal to L by 2 root 3. So the radius of gyration is also available to us. किसी भी की चीज़ का moment of inertia mk square. So if the mass is located at a particular point from the axis, concentrated, the total mass of the rod becomes a point mass multiplied with k square is the radius of gyration. So अब आपने shift करा है थोड़ा सा axis. Either you can take again this approach. This is my dx located at x. My mass density is m by L. My width is dx multiplied by x square is my di. But this time you are going to do 0 to L because you're wearing 0 to L निकालना है आपको. So you can put it and get the answer. So this will be m by L x cube by 3 0 to L is equal to ml square by 3. If you want to find the radius of gyration, then ml square by 3 is equal to mk square. mm gone, k is equal to L by root 3. L upon 1.732. So you can calculate this 17.7 are. So अगर ये पूरा rod का mass x के, if this total is L, it is located at around 0.7 L. The whole mass is located here. Then this is your radius of gyration, okay, which is this. The rod becomes a single point. So just remember each one of them. Rod का कैसे निकलता है? ये center में ml square by 12 on an axis which is tangent to the parallel to the perpendicular axis. एक side पे ले गए ml square by 3. और एक जो बहुत important figure है, that is cylinder. So moment of inertia of a cylinder. Now this is your cylinder and you make it rotate around an axis passing right through its center. तो यहीं इस axis के around ही एक ही जगह पे खड़ा होकर इस जगह पे rotate कर रहा है. Apply the same rule. The integration I is equal to mr square through
सर आवाज थोड़ी कट रही है सर.
there. Yes.
बीच में थोड़ी आपका माइक थोड़ा सा खराब हो रहा है.
Loose है. I think it's slightly
एकदम बहुत पतली सी
loose.
आवाज आने लग जाती है बीच में.
Is it better now?
हाँ जी.
Okay. So the moment of inertia of a cylinder is this.
ठीक है.
ठीक है. तो अब अभी I'm not deriving this, but in your school they can ask you that. So this is a hollow cylinder, mind you. So ये हमने निकाला है moment of inertia of a cylinder which is hollow, but you can have another hollow का मतलब है the mass is distributed only on the periphery. मतलब जैसे पानी का ग्लास होता है वैसे, right? But if you can also have a mi of a cylinder which is a solid cylinder, okay? Solid cylinder मतलब एक पूरा का पूरा भरा हुआ. So this is your cylinder and this is completely filled with material जिसका भी बना हुआ है, and this is the axis. You can apply integration again on top of this and calculate the. तो इसका this is called its own axis. This axis is the axis own axis of cylinder. Generally जो questions होते हैं जब आते हैं rotational में, तो there is an inclined plane, okay, like this, and so this is your inclined plane, and what you do is you have a cylinder coming down, okay, rolling, it is coming down. You can have a disc which is coming down, okay, a solid disc is coming down, तो उसका axis ये है. A ring can also come down, okay, a rod can also come down, okay, this is your
ठीक
rod. मतलब यही चार, और एक जो शेप हमारी इंपॉर्टेंट है, that is sphere, hollow sphere as well as the solid sphere. Hollow sphere हो जाएगा ऐसा जैसे ये दिख रहा है. If you draw a solid sphere, then the solid sphere is like a shot put. So this could be a basketball, but this is a solid sphere. The mass is distributed throughout. अगर दोनों सेम रेडियस के, ऑब्वियसली इसका मास बहुत ज़्यादा होगा, बट हो सकता है इसको पिघाल के दे मेल्ट दिस एंड क्रिएट दिस, द बॉल बिकम्स वेरी स्मॉल and some radius is created. The volume remains the same. Okay.
ठीक
So you can also have a cylinder. The cylinder is being made to revolve like this. So you keep it on the ground, drum रख दिया और यहाँ पे fix कर दिया और अब ऐसे घूम रहा है ये drum. Okay. And also make the drum move like this on the ground. So you have to see what axis is being referred to, and therefore you have to memorize all the shapes. So if you go to the page number 7.33, you will find all the values written for each and every figure. There are around 21 values that need to be memorized. I have given you a glimpse of some derivations. कभी स्कूल में पूछ लेते हैं, but otherwise if they ask you numerical, we will see how to solve them. But it's very useful concept. Moment of inertia is the rotational mass or the resistance which is offered by the body to turning.
ठीक
Okay. And if we talk about for example, this is coming down on an inclined plane. ये सब inclined plane से नीचे आ रहे हैं, right? Now they are also moving linearly. So it's rolling. They're moving. Translatory motion is also there, and they also exhibit rotation. So they have both the kinetic energies. Okay, so the kinetic energy they have is obviously when they're at rest at the top, they only have mgh at the top, and then mgh starts getting converted into kinetic energy, which has two parts because of rolling. One is half I omega square, the other is half mv square. Since this is pure rolling, v is equal to omega r at the center of mass. We did this. Okay, यहाँ पे रेस्ट पे होता है, यहाँ पे v होता है और यहाँ पे 2v होता है in the case of pure rolling. So here it is at rest. Okay, and this is half I omega square plus half mv square. So v is equal to omega r. You can put the value here and get the total kinetic energy. So we write it total kinetic energy made up of two parts in a situation. And even on a ground, if a cylinder is moving, even on a ground, you can calculate its आगे भी जा रहा है और roll भी कर रहा है. So v is so half I, whatever work you do on it gets converted into half I omega square plus gets converted into half mv square. Like work is force into distance, so you can apply a torque and you can rotate it by, so torque into theta will give you the work done, and that whole of the work gets converted into this. So whenever you do rolling, you see a rolling body and you say ki these bodies only roll, by the way. They will slide also, they will skid also, but so far, since we've only done pure rolling, so to situation pure rolling.
ठीक
These are for the center of mass.
ओके
When we will do sliding and all that, you will realize that if you have a sphere like a tire, then the velocity of center of mass is not going to be v is equal to omega r. Okay, so अगर ये बॉडी रेस्ट पे रहती है, रोटेशन की वजह से इसको पार्टिकल को यहाँ पे मिलती है वेलोसिटी इस साइड, और ट्रांसलेटरी मोशन की वजह से ये वाली वेलोसिटी मिलती है, तो ये रेस्ट पे रहता है, ये v रहता है सेंटर ऑफ मास, और ये 2v हो जाता है क्योंकि यहाँ रोटेशन का v प्लस ट्रांसलेशन दोनों का v बराबर है तो एक ही डायरेक्शन में तो 2v0, बट हर बार ऐसे नहीं होगा. दिस इज ओनली एप्लीकेबल टू द सिचुएशन ऑफ प्योर rolling. So we will come across situations where there is no pure rolling, and when you write the equation like this, v will not be equal to omega. Maybe the body is rotating less but moving forward more. पहिया जो है बहुत कम घूम रहा है लेकिन बॉडी स्लाइड कर रही है. जैसे कि मिट्टी में कई बार टायर फंस जाता है. यू राइट, यू हैव टायर, नाउ इट इज, देयर इज लॉट ऑफ रोटेशन बट देयर इज नो मूवमेंट ऑफ द टायर फॉरवर्ड. वो फंस जाती है रेत में, राइट? तो दैट
Okay.
दैट इज नॉट अ केस ऑफ रोलिंग. एंड सिमिलरली यू विल सी, आपने ब्रेक लगा दी है, पहिया घूम बहुत कम रहा है, स्लाइड ज्यादा कर रहा है, राइट? सो देयर द ट्रांसलेशन मोशन wins over the rotational motion. So that is not a pure rolling. So दोनों example, motorcycle getting stuck in daldal, or for example this wraith in a desert, and vice versa. When you apply a brake, the tire is moving slowly but more sliding, are not the examples of pure rolling. So we will study them also, but for the time being we're just taking it very easy and saying that rotational kinetic energy is equal to half I omega square plus half mv square, and v is equal to omega r. Where does this come from? Because we are assuming case of pure rolling.
Okay.
So we have to use moment of inertia a lot of places, and gradually, okay, now we will start doing numericals on moment of inertia. Because you're very raw and new to this chapter, so I'm just going step by step, which is getting you friendly with the terminology, jargon, and all of that. Once you're comfortable, numericals will be very simple, but theoretically you should have a good grounding in this chapter. इसमें वो नहीं है ना, न्यूटन्स फर्स्ट लॉ सेकंड लॉ सीखा और करना शुरू कर दिया. So it takes time. Lengthy chapter. All right. Anyway, so let's talk about the first question. Okay, so this is your, so you have a wheel available to you. So that's your wheel, and the radius of gyration of this wheel is given to be 25 centimeters. Okay, so the K is given to be 25 centimeter, and the mass of the wheel is 8 kg. Okay, and it is rotating with omega is equal to 300 rpm. Question is, what is the moment of inertia of this wheel? The omega is given, mass is given, k is given, and you have to also the radius of gyration is given. So you have to find the moment of inertia is given by mk square.
हाँ जी.
Mass is 8 kgs.
8 into 25 square.
Yes. Convert it into meters and get the answer. No significance of omega. Moment of inertia is not impacted by the omega, but it is impacted by the mass and the distance from the axis. That's all. This is highly misleading.
हाँ जी. ये बस घुमाने कंफ्यूज करने के
हाँ
लिए.
हाँ, जिनको नहीं पता वो कुछ करेंगे.
हाँ जी.
उनको पता, उनको फिजिकल डिमेंशंस पे डिपेंडेंट है, मतलब शेप एंड साइज एंड ऑल दैट, नथिंग टू डू विद.
तो कुछ
ऑलराइट.
क्वेश्चन जेई में भी ऐसे होते हैं, आलतू
हाँ
फालतू की
होते हैं,
वैल्यूज दे देते हैं
बहुत सारे, बहुत सारे.
कंफ्यूज करने को.
क्लैरिटी होगी तो इट रियली रियली इज. ओके, सो यू लुक एट दिस. सो ये आपका m1 and this is your m2, and now he will tell you where is the axis. So the axis of rotation is here. Maybe these are beads and you have put fixed them here, and now this is your axis about which you are rotating. So this is your axis of rotation, and so these are the three masses, m1, m2, m3. It's an equilateral triangle. The length is a. You can see the mass m1 is through the axis, so it will have no moment of inertia. No turning, no turning is possible. It is already, r is 0 for it. So whatever moment of inertia is there is for m2, m3, right? So this is a by 2. Obviously, it's a perpendicular bisector of a equilateral triangle, and therefore the total moment of inertia will be because of m2 a by 2 whole square plus m3 a by 2 whole square is equal to m2 a square by 4 plus m3 a square by 4 is equal to, if all the three masses are equal, fair enough, otherwise just leave it here, m2 plus m3. Answer, kilogram meter square. Clear? No moment
Yes,
of
sir.
inertia for m1 for obvious reasons. There is no r available. Even if you want to write m1, my question is, what is the distance of m1 from the axis? 0 square. It is already on the axis. If a body is on the axis, its moment of inertia is 0. It offers no resistance for turning. Doesn't turn. Okay? Question number
Okay.
3. So let's do a similar question. Now we have something on the square. Okay, so this is 5 kg, this is 4 kg, this is 2 kg, and this is 3 kg. And these are the diagonals, straightforward. 1 meter is the length. This is 1 meter, 1 meter, 1 meter, and 1 meter. So obviously this is diagonal is known to you, root 2. Half the diagonal is also, this is your axis, and this axis is passing through the point of intersection of the diagonals, but is perpendicular to the plane, which means it is pointing inward of the screen. Okay, so it is like this. It is going, this is your axis. 3D mein. That's your axis. Question is, you have to find the moment of inertia about this axis. Nikalo. Try. About axis which is perpendicular to the plane of this square system of particle. And but axis is इसको छेदता हुआ जा रहा है. It's perpendicular to the lamina.
के की वैल्यू निकालनी है.
Yes.
तो के एक यहाँ से.
No, we have not asked you moment of radius of gyration. That is the second part. First is calculate the moment of inertia. So first part, calculate the moment of inertia of this system of particles about O when the axis is passing through O, when the axis is perpendicular to the square plane, which is made by these four masses. So ऐसे है, उसके perpendicular axis है, तो ये चारों ऐसे घूमती हैं उसके अराउंड इस एक्सिस के. अगर आप साइड में से बनाते तो it would look like this. Okay, so this is lying on the ground, four masses lying here, and the axis is perpendicular here. And these are now rotating like this. सारे के सारे ऐसे घूम रहे हैं. Okay, they have a fixed distance. Diagonal का आधा. So if this is root 2, the diagonal, root 2 meters, what is the half of this? Root 2. Root 2 by 2. So x, or the distance of each one of them from the axis, is 1 by root 2. So the moment of inertia is 2 into 1 by root 2 square plus 3 into 1 by root 2 square plus 5 into 1 by root 2 square plus 4 into 1 by root 2 square. Any doubts? कैसे आया? Half the diagonal, that is the distance of each particle from the axis we have considered.
हाफ
Not
द
clear?
डायगोनल. एक मिनट
Of course. Look at it.
ओके. अच्छा, नहीं डायगोनल तो वो है ना.
ये रहा
डायगोनल तो
एक्सिस, तो
उसमें
ये
आ
रहा.
जाएगा. रूट 2 है
दिस इज द,
डायगोनल. रूट
हाँ, और उसका
2 बाई
आधा ही
2.
तो है O.
अच्छा, 1 बाय रूट.
So I did root 2 and then I divided by 2 because the distance of the particle from the axis is this much.
ठीक है.
All right. Part 2 of the same question. Now the axis is the side AB. What will you do now? एक्सिस यहाँ पे आ गया ना, परपेंडिकुलर है, बस ए बी के ऊपर है एक्सिस, और सारे पार्टिकल ए बी के अराउंड. ए और बी के ऊपर तो दो पार्टिकल है, मतलब ये वाला पार्टिकल यूं घूम रहा होगा ए बी के अराउंड, और नीचे वाला ऐसे जाएगा ऐसे. तो ये स्क्वायर जो है ऐसे रख के स्क्वायर पूरा घूम रहा है ऐसे. वो ए बी पे फिक्स कर दिया वहां पे उसको, जमीन में फिक्स्ड इट एट ए बी, एंड नाउ इट इज रोटेटिंग. So calculate the moment of inertia of the same system of particles about AB. A और B के ऊपर 4 kg और 2 kg हैं, so they have no moment of inertia whatsoever, right? There is no moment of inertia
हाँ जी
on for 4 and 2. The whatever moment of inertia is there for 5 and 3, and you know the perpendicular distance, right? 1 meter है दोनों का.
हाँ
So m5 into 1 square plus 3 into 1 square, 8.
ओके
5 kg is at a distance of 1 meter, right?
हाँ जी
So 5 into 1 square plus 3 into 1 square. ठीक है? All right. Now calculate the moment of inertia around the diagonal. So calculate the moment of inertia about the diagonal. Say A, C. This is A, B, C, D. You have to find the moment of inertia around A, C.
अराउंड ए सी
Yes.
4 into 1/√2 square plus
Write
5
it
into
down.
1/2.
करो ना. Do it. Show the axis. Calculate the axis around. अच्छा, you were saying that 4 का तो कुछ होगा ही नहीं. A C है ना. 4 का
हाँ
तो कोई होगा ही नहीं because 4 is on the axis. So the whatever rotation is happening is around AC, which means ये वाला जो मास है वो ये ऐसे घूमेगा और ये वाला मास ऐसे घूमेगा.
ओके 5 into
Right? 1/√2 whole square. Yes. Perpendicular distance. Yes. And plus 2 into same. Correct.
it would be 2.5. Need sorry
Yeah.
3.5.
5 and 2 7. Yes. 3.5 kilogram meter square. ठीक है. Fair enough. Okay. So question number 1, 2, 3, 4. Question number 5. Let's do question number 5. The question number 5 is this: the moment of inertia of a circular disk. So this is your circular disk, and it's a disk. Remember, it's not a ring. तो पूरी भरी हुई है ये. Okay, and the moment of inertia is 100 gram centimeter square. That's your moment of inertia, and now you have to find the moment of inertia about the tangent. So that's your tangent. ठीक है, tangent बना लेते हैं इसके ऊपर. So if you memorize it, you can write in one line. If you don't memorize it, the 21 values, then you end up deriving this. Derive करने को बोलते हैं तो derive करना. अगर सीधा moment of inertia पूछा है तो कई क्वेश्चंस जब जेई में आते हैं, स्कूल में आते हैं, उसमें फिर लिखा होता है अबाउट द टेंजेंट. तो डिस्क का टेंजेंट के अराउंड क्या फॉर्मूला होता है? 1/mr²/4. सो यू टू मेमोराइज इट.
1 by mr square.
हाँ जी, mr²/4. So I tangent of a disk, when the tangent is parallel to a diameter, right? Not random tangent, मतलब but अब diameter के parallel वाली situation में एक तो perpendicular भी होता है ना इसके. When you can have a disk like this, there is a perpendicular axis, and you can draw tangent parallel to the perpendicular axis. But when I say tangent, I mean the reference is the parallel line to the diameter. So that's your dia, and the axis is parallel to the dia. So I tangent but parallel to dia. Okay, that's a condition. So the answer is mr²/4. If you don't remember it, second part of the question, calculate the moment of inertia of this disk.
1 by mr square.
हाँ, किसका?
Tangent वाला I tangent.
हाँ, so पहले तो you remember that वो जो अराउंड द डायमीटर है, जस्ट होल्ड ऑन, दिस इज योर डायमीटर, राइट? तो इसमें तो एम आर स्क्वायर बाय 4 है, आई टोल्ड यू द फॉर्मूला डायरेक्टली।
अच्छा, एम एस स्क्वायर बस।
तो अब इसके पैरेलल मूव हुए ना, यू मूव पैरेलल टू इट, सो अप्लाई द पैरेलल थ्योरम। सो एम आर स्क्वायर बाय 4 प्लस एम आर स्क्वायर एक्स्ट्रा एम एक्स स्क्वायर प्लस एम एक्स स्क्वायर होता है ना एक्स्ट्रा, अगर पैरेलल एक्सिस थ्योरम लगाएंगे। सो यू अप्लाई पैरेलल एक्सिस थ्योरम एम आर स्क्वायर, सो दिस विल बी 5/4 एम आर स्क्वायर।
मास क्या दे रखा है? अच्छा, मास नहीं में पूरा।
हाँ, वो तो आपको दिया हुआ है ना, मास इज 100 mi दिया हुआ है आपको
हाँ
इसका,
जी।
about its diameter. So if you know about the diameter, so basically 5/4 of that, right? So if you do 5/4 of 100, that is 125
ठीक है।
आंसर। तो पैरेलल एक्सिस थ्योरम की अंडरस्टैंडिंग और इस बात की मेमोराइजेशन की,
और और
टेंजेंट
25 आ जाएगा।
जी 125 about the tangent, right? 5/4 of about the diameter, sorry 5 times the diameter,
नहीं, और हाँ
5
ठीक।
टाइम्स आ गया ना, 5 टाइम्स आ गया, क्योंकि एम आर स्क्वायर बाय 4 इज अराउंड द डायमीटर, उसका 5 टाइम्स कर दो तो 500 आ जाएगा एक्चुअली। दिस इज एम आर स्क्वायर बाय 4 ना, दिस इज गिवन टू अस, द एम आई which is given to you is the mi dia, and then you applied parallel axis theorem and calculated it. Got it?
यस।
Okay. Okay, now next one. So you have a cylinder, and the cylinder, this is your cylinder, and the length of the cylinder is height, whatever you want to call it, is 1.5 meters. You will have to refer to the chart, obviously, and the radius is 0.05 meters, and the density is 8 into 10 raised to power 3 kilogram per meter cube. Okay, and there is a, you have to calculate the moment of inertia of this about the axis of the cylinder. So if you refer to the axis of the cylinder, that's your axis of the अपना axis cylinder का अंदर ही है इसके बीच में. And this is the case of a, since the density is given, we will assume this to be a, इसने दिया नहीं है, he should have mentioned it's a hollow cylinder, or is it a बताया नहीं है ये क्या है ये. So let's assume this is the case of pi r square h volume. So this is a solid cylinder, ले लेते हैं इसको हम. लिखा होना चाहिए था एक्चुअली क्वेश्चन के अंदर clearly that this is a solid cylinder, right? So that you can apply the moment of inertia formula of a solid cylinder of those 21. So if you talk about a solid cylinder, it's half mr square. mr square by 2 है for a solid cylinder. I for a solid cylinder about its own axis. So this is its own axis. You know the volume. So you can calculate the mass. Is that clear?
हाँ जी।
ठीक है. Let's try and do. Now let me give you a square. So this is a square. Okay, this is a square, and what you're given is spheres. Okay, so you can refer to the chart, and so 4 spheres are given to you. I think they're identical, and this is the sphere. Okay, so now these are 4 spheres of dia meter, which is 2a each, and the mass of each sphere is m. And these are lying at the corner of a square each of the side b. Okay, तो स्फीयर है चार और ये सिस्टम ऑफ पार्टिकल्स की तरह बिहेव कर रहे हैं, बट इंडिविजुअली भी इनका मोमेंट ऑफ इनर्शिया बाय द वे, राइट? सो यू हैव टू कैलकुलेट द मोमेंट ऑफ इनर्शिया ऑफ दिस सिस्टम अबाउट वन ऑफ द एक्सिस, किसी भी एक पर्टिकुलर साइड के, सॉरी, अबाउट निकालना है. सो यू कैन टेक एनी साइड ऑफ योर चॉइस. सो टेक दिस फॉर एग्जांपल, राइट? लेट्स टेक दिस, ये वाला ले लेते हैं, और इसका थोड़ा सा कलर लेट्स चेंज इट टू some other color. Now, if you notice, sphere का we know, right? And around its own axis. तो इस spherical shaped solid sphere है, इसका फॉर्मूला होता है 2/5 mr square. For a solid sphere, the moment of inertia is 2/5 mr square. तो एक इंडिविजुअल का तो पता ही है, राइट? तो मेरे पास ये वाला एक्सिस है जो मैं कंसिडर कर रहा हूँ साइड. तो अगर मैं बात करूं, इनका नाम रख लेता हूं मैं ए, बी, सी एंड डी. Okay, now if you consider this A, B, C, D, then the moment of inertia of A, B, C, D into 4, right, is straightforward part. But let's do it systematically so that हमें clarity भी हो जाए कि हम कर क्या रहे हैं इसके अंदर, right? So what we are doing is this. So if you consider B, right, B के बाद the axis of rotation for the sphere B is located at this distance. So this is a parallel axis theorem. इसका जो अपने axis पे है, which is 2/5 mr square. So this is your moment of inertia for the situation of B, right? So this is IB, and this is equal to IC is equal to 2/5 mr square. And we will apply the parallel axis theorem also for B, because the axis of rotation of B is located at B distance. So mb square is the extra for both of them. But if you look at A, उसका 2/5 mr square है, और D को अगर आप देखोगे तो वो भी 2/5 mr square है, because वो तो खुद तो एक्सिस के ऊपर ही है. So यहाँ पे on 2 we applied parallel axis theorem. So if you add all of them, that's the moment of inertia of yours for the whole system. Tell me if you have a doubt on this. क्लियर है ना? बिल्कुल. दो में पैरेलल एक्सिस थ्योरम. तो ऐसे ही आपको क्वेश्चन आएंगे जहां पे परपेंडिकुलर एक्सिस, पैरेलल एक्सिस, परपेंडिकुलर एक्सिस, पैरेलल एक्सिस, तो ये चलता रहता है. लेट्स मूव टू द नेक्स्ट वन. हाँ जी, पूछो.
इसमें कितने टॉपिक्स और बचे?
इसमें मोमेंट ऑफ इनर्शिया है, एंड देन वी विल हैव टू डू द रिलेशनशिप बिटवीन टॉर्क एंड मोमेंट ऑफ इनर्शिया. डायनेमिक्स स्टार्ट होगा इसके बाद. डायनेमिक्स, विच मीन्स वो जो न्यूटन्स वाले क्वेश्चन होते हैं, they will start after this, and the last topic will be rolling motion, and then it ends. Rolling is a bit difficult, not difficult, थोड़े से cases अलग अलग बनते हैं उसके अंदर. So डायनेमिक्स है इसका मेन जो है, मतलब वर्क पावर एनर्जी इसका, और न्यूटन्स वाले जो क्वेश्चन होते हैं,
फिर इजी
टॉर्क
है
वाले,
लग रहा है।
हाँ वो स्ट्रेट फॉरवर्ड होते हैं, मतलब थोड़े से कॉम्प्लिकेटेड होते हैं, बस समझ में आ जाएगा. बट यू हैव टू नो दीज फंडामेंटल्स, बिकॉज शेप्स विच आर इन्वॉल्व आर numerous. So they will give you 3 shapes and they will ask you which one of the following will reach the fastest. So you should be able to understand the moment of inertia of each one of them qualitatively and decide immediately कि कौन सबसे पहले नीचे आएगा, etc., etc. Many questions are there. So, and anyway, moment of inertia in itself is going to be asked. Okay, so let's consider another situation. You have 2 point masses, and they are now connected by a rod, and so this is your situation, and this is your, so there are 2 masses, each of 2 and 2 kg and 10 kg, and they're connected by a weightless rod of 1.2 meters. Okay, 1.2 meters, and calculate the moment of this system about an axis which is passing through the center of this mass and perpendicular to the system. So the connecting mass, okay, the weightless rod, which is of length 1.2 meter, this is the weightless rod. And we have to find the moment of inertia about through the center of mass of the system. तो पहला step है कि let the center of mass be here. We don't know इन दोनों का center of mass कहाँ पे. So this be x. This will be 1.2 minus x, right? So we will first find the center of mass. About the center of mass, what is the quality? m1 multiplied by x will be equal to 1.2 minus x into 10.
ठीक
Okay, so m1 x is 2x is equal to 1.2 minus x multiplied by 10, and 2x is equal to 12 minus 10x. 12x is equal to 12, x is equal to 1 meter. So it is heavily twisted towards 10 kgs, the center of mass. The center of mass is actually 0.2 meters from this. So we know the center of mass is here, और यहीं पे हमें वो भी निकालना है. ये हमारा axis actually फिर, right? This is our axis. So you have to calculate now the moment of inertia of this system is equal to mr square. So this is 1 meter. इसका हो जाएगा 2 into 1 square, और 10 kg का distance है 10 into 0.2 square is equal to 2 plus 10 into 2 by 100 is equal to 2 plus 1 by 5 is equal to 2.2 kilogram meter square. Answer. Sorry, is the calculation okay? 0.24 by 10. Sorry, this becomes 2.4.
ठीक
Clear है? All right, now you are given a situation of a rectangular bar. This could be a chocolate for all you know, okay? So just a rectangular bar, and you have to find the moment of inertia of this rectangular bar. So let's draw this rectangular bar like this, and this is your rectangular bar, and the so thickness is there. There's an axis which is parallel to the thickness, which means this axis, right? So thickness के साथ ही है, और इसके dimension दे रखे हैं, mass दे रखा है. Length is 112 centimeter. The breadth is 3 centimeter, or thickness is, sorry, the breadth is this. Okay, so breadth is 3 centimeter, and the thickness of the chocolate is 2 centimeter. The axis is said to be passing through its center. मतलब कि अगर क्यूबॉइड की बात करें तो जो डायगनल्स हैं उनको अगर हम कनेक्ट करें तो क्रॉसिंग, राइट, इधर ये जो मैंने लाइन ड्रॉ करी है, इट शुड हैव पास थ्रू द सेंटर समवेयर हियर. So I'll just rub this off this line. I will redraw this, connect these two. So cuboid is complete, but the axis is not here, right? So the axis is passing through the center of the cuboid, center of mass. So E axis है basically. Can you calculate this, the moment of inertia of the cuboid? So it's a bar, remember. How is it behaving? What do you think it is? Bar. It's a rod.
ओके
रॉड तो ऐसे होती है ना, लेकिन सिर्फ रॉड इज ओनली दिस, राइट?
हाँ जी
बट दिस हैज टू पार्ट्स टू इट नाउ. ये बार बन गई. So one moment of inertia it has is the obvious one, which is applicable to is ml square by 12, and the other is across its breadth, which is mb square by 12. So moment of inertia of a bar is actually nothing but sum of moment of inertia of two rods built into one. They look like a bar. Let me just show you the figure. Okay, moment of inertia. Why do we say that moment of inertia of a bar is ml square by 12 plus ml square by B. Moment of inertia of a rectangular bar. So धीरे धीरे you will see it slightly gets into not a straightforward arena, but makes your life slightly difficult. कि अच्छा जी अब rectangular bar का कोई formula तो direct है नहीं. So how do we now imagine? They can ask you moment of inertia of a ellipse. Maybe not now, later.
ठीक।
सिविल इंजीनियरिंग में होता है बार का जो डेरिवेशन है बेसिकली.
हम्म।
There's a standard rule in engineering mechanics. ml square by 12 plus ml
आई होप
square.
सिविल इंजीनियरिंग में ज्यादा से ज्यादा क्लासिकल मैकेनिक्स हो।
और स्टैटिक्स काफी यूज होती है
हाँ जी,
क्योंकि वो
वही
बिल्डिंग
मतलब।
में खड़ में यू टू मेक द बिल्डिंग.
वो ऑप्टिक्स ना घुसो दे बाहर फालतू में।
ऑप्टिक्स
ऑप्टिक्स, इलेक्ट्रोडायनेमिक्स, इलेक्ट्रोस्टैटिक्स, ये सब
सब
मिलने
कुछ
चाहिए।
होता है, सब कुछ होता है उसके अंदर.
फर्स्ट ईयर के बाद सब खत्म हो जाएगी।
हाँ, finished. Yeah, I think you can just memorize this, that the moment of inertia of a rectangular bar is ml squared 12 plus mb squared by 12. When it is the axis is parallel to the thickness. ये thickness है इसके parallel axis ये वाला. Okay. थोड़ा यूनिक है और सिविल इंजीनियरिंग के कोर्स में है, इन्होंने पूछ तो लिया है. Let's move to the next one. So you have now the question on radius of gyration. Okay, so radius of gyration, very important. So you have to calculate the ratio of radius of gyration of a circular ring. So you're given a circular ring. This is your circular ring, and there's a disc of the same radius, right? So this is a disc which is full. ये पूरी मटेरियल से बनी हुई है डिस्क. इन दोनों के रेडियस ऑफ गायरेशन को कंपेयर करना है गिवन दैट दे आर ऑफ द सेम रेडियाई. Radius is given to be identical for both of them. So this is their radius about the axis pathing to the center and perpendicular to their planes. So this is the axis perpendicular to the plane. And there, yes, and it is also given that the mass is also identical. But obviously, disk के case में you can see the distribution of the same mass becomes closer to same mass है, तो वो आपको डिस्क बनानी पड़ेगी सेम रेडियस की. तो वो जो मास रिंग में दूर है बहुत, वो रिंग के केस में काफी पास भी आ गया कई जगह पे रिंग के आसपास, और थोड़ा सा ही मास दूर है. बाकी रिंग में तो वो पूरा मास बहुत दूर है एक्सिस से. नाउ ट्राई दिस, कैलकुलेट द रेडियस ऑफ गायरेशन. It is given that the mass moment of inertia of a ring about the center is mr square, and the moment of inertia of a disk about its center is mr square by 2. So this will be what? Mk square. This will also be mk square. कट जाएगा और so k is equal to r and k is equal r by root 2. So this is first ring का radius of gyration. This is that of a disk. So k ring divided by k disk is equal to r upon r by root 2. So radius of gyrations compared, root 2 is to 1. रिंग का ऑब्वियसली बड़ा रहा है क्योंकि रिंग में मास डिस्ट्रीब्यूशन पेरिफेरी पे है, जबकि सेम मास जब आप उसका डिस्क बना लेंगे तो वो एक्सिस के पास भी बहुत सारा मास आ जाएगा सर्कल्स में. So you can see this is one of the chapters which is probably lengthiest.
लेंथीस्ट नहीं एंड हार्डेस्ट भी.
हाँ, हार्ड है काफी. मतलब जब क्वेश्चन आएंगे तो you just unbelievable questions are there. I saw one
पर ऐसा
question.
लग रहा है कि आप जेड वहां से बैठे हो.
हाँ, you can actually feel this is a cylinder, but actually it's a rolled carpet, and the carpet opens by rolling, okay, in steps. So when the carpet is completely open, how much time will the carpet take to roll and complete. So the moment of inertia keeps on reducing in every rotation. You have to मतलब think through what exactly is happening and कैसे करना है इसको solve. तो मतलब एक से बढ़कर एक rod है. This is a rod, right? The rod is struck on balls.
एडवांस पे पक्का बहुत सारे आएंगे इसमें, तो बता
आते
रहा
हैं
हूँ।
आते हैं. Therefore, you should be very well prepared. A lot of people leave this topic. This can be an edge if you prepare it well. So I'm not getting into now the simple ones. I believe you will be able to solve
तो
some
सिंपल
of
वन
them.
से पहले शुरू करते हैं।
हाँ नहीं ये हो गया ना सिंपल. और कितने सिंपल करेंगे? फॉर्मूला फिटिंग ही हो रही थी अभी तक तो.
अच्छा।
Okay, now let's go to the rotational kinetic energy. So let's move into the topic of rotational
काइनेटिक एनर्जी।
kinetic energy, right? So rotational kinetic energy की अगर हम बात करें तो there is a disk of mass is equal to 1 kg
ठीक है।
and the radius of the disk is 0.2 meter and it is rotating about an axis which is passing through its center. Obviously, so this is your, and it is rotating about an axis which is passing through its center. Okay, ये center है इसका. मतलब 3D में है ये और ये center है इसका. So this disk is, this is the perpendicular to the plane of the disk. The radius is 0.2 meters, etc. And omega for the disk is given to be 30 upon pi rotations per minute. Okay, you have to calculate, and it is rotating, by the way, it is not rolling. So it only has a half I omega square as a kinetic energy. So first of all, you will see it's a disk. Apply the formula of mr square by 2, then apply the omega square, get the rotational kinetic energy answer.
ठीक।
Okay. Next, so now you have a flywheel, which we know what is a flywheel. It's a mechanism to remove jerks out of motion. And so flywheel is moving with omega is equal
कहीं पे जो
to
बड़ा सा लगा होता
60 revolutions per RPM है.
है। नहीं, एक मिनट, ये तो फ्रीक्वेंसी है, रैड नहीं होना चाहिए?
क्या?
रैड पर सेकंड।
हाँ, so you can write the way you want to. You can also write it as revolutions per minute. RPM is
पर
generally
रेवोल्यूशन
revolutions,
फ्रीक्वेंसी नहीं होती सर?
angular
टू
frequency.
पाई,
हाँ,
2 पाई भी?
omega is equal to 2 pi f frequency. 2
हाँ जी,
pi
टू
mu
पाई भी,
होती है, न्यू
न्यू,
न्यू.
2 पाई न्यू, सॉरी।
हाँ, equal to 2 pi by t. So it is revolutions per minute, RPM. You can convert it to 2 pi by 60 and you will get as 2 pi radians per second. So this can also be converted into 360 into 2 pi by 60. So this
अच्छा,
is equal
मतलब
to
एक ही बात है ये।
12 pi. नहीं, these are SI units. ये ऐसे लिखने का तरीका है RPM.
अच्छा
RPM
अच्छा,
has to be converted
ऐसे
into
मतलब
rad.
रैड।
Yes. ठीक है? All right. So the energy is which is spent on achieving this. That is the velocity omega 1 is increased from 2 pi to 12 pi. This is the increase in energy, and this energy which is spent is 484 joules. So you do a work of 484 joules on a flywheel which is already rotating, and the speed of its revolution increases to 6 times, becomes 12 pi when you put this much positive work on it. So which means whatever work you have done has actually got into useful increase in the rotational kinetic energy, right? This is it. So with the help of this, you can calculate the moment of inertia. Take I common, you know omega 2, you know omega 1, you can calculate I. Answer. So this was energy for you. Okay, now let's say planet Earth is given to you, and the Earth is rotational kinetic energy of Earth is to be calculated. The moment, and it's a sphere, by the way. Earth is a solid sphere. So the 2 by 5 mr square, its moment of inertia, the radius is given to be 6,400 kilometers. Okay, so you have to calculate the moment of inertia, which is 2 by 5 mr square. Calculate the moment of inertia, and then since it is rotating only, the earth is spinning or rotating only, so the energy is half I omega square. Put the value of moment of inertia of earth. Moment of inertia of a sphere is 2 by 5 mr square, and into omega, the revolution of earth is given to be, uh, you will have to find it, the angular velocity of the earth. So omega for earth, so इसका अपना चक्कर लगाने के लिए 2 pi into 6,400 kilometers into meters, it takes you 1 day to complete one revolution, right? Full 1 day. So 24 hours go 60 into 60, that's your omega for earth radian per second. Put it in the formula of half I omega square, half I omega square. Khatam. Right. Let's move to the next one. This was clear, right? Earth is rotating. What is the kinetic energy contained by Earth? Half I omega square. Earth is to be treated as a solid sphere. The angular
Okay.
velocity of Earth is 2 pi r. ये जो पूरा radius ऐसे घूमता है, divided by the time it takes to complete the rotation is 1 full day. 24 घंटे. Right. Next. Now you have a meter scale. So you have a meter scale like this.
मीटर स्केल.
Yeah.
अच्छा.
Futta. Okay,
फुट्टा.
it falls like this. So it's a rod, right? And the axis is fixed here. So it's a axis at the tangent. So ml square by 12 तो हमने निकाल ही लिया था. But we should instantaneously realize कि यार ये rod है और it is about a axis which is on the ground. तो बिल्कुल tangent पे है rod के. So I'm just looking at the thin rod, and at the thin rod, at the end, the moment of inertia is 1 by 3 ml square. So whatever it is, इसका moment of inertia तो मुझे मालूम है 1 by 3 ml square. So it falls on the ground flat. Obviously, इसका center of mass यहाँ पे है. So the loss in potential energy you have is, so initially when you're standing, your potential energy is mg L by 2, right? यहाँ से पूरा mass is concentrated here. It is L, तो L by 2 पे potential energy, and this mg L by 2 is now rotating and getting converted into half I omega square. I we know is 1 by 3, so we can find the omega of this figure. So answer आ जाएगा आपका कि what is the loss in potential energy, which means because it will fall flat on the ground, the center of gravity will be on the ground. So no H. So this complete potential energy which you have here actually gets converted into complete rotational kinetic energy.
ठीक.
So question is, you have to find the and it is given that it does not slip about this point, right? It is fixed. यहाँ slipping नहीं होती कि friction है जिस slide ही कर गया है, fixed है वहाँ पे, it doesn't move. Okay, you have to find the velocity with which the end B strikes the ground. Now, if you're able to find omega, then V is equal to omega r, and the radius for omega तो एक बॉडी जो रोटेट करती है उसका ओमेगा हर पॉइंट पे सेम होता है, उसका ट्रांसलेटरी V हर जगह अलग होता है जो होता है V इक्वल टू वी आर. So omega you will be able to find from this loss of potential energy is equal to gain in rotational kinetic energy, and you will find omega. So omega आ गया, and now put V is equal to omega r. So this is where you will strike, and you will use the whole length as the radius, and you will say V is equal to omega into L. Omega, you got it from the law of conservation of energy. It's a conservative field in which you're falling, gravity. So the potential energy will get converted into the kinetic energy. And since the rod doesn't move forward, there is no half mv square. It stays there. ठीक है? ठीक है, what we will do tomorrow, and I've run out of steam now, we will do more practice on energy type of numericals. थोड़े से इसमें tough type के numerical होते हैं, दो तीन ही हैं जो आपको आने चाहिए, and we will do some 2-3 of those numericals where you will see how the combination is used of half mv square and half I omega square work power energy type के. And then we will move to the next topic tomorrow, which is the topic of torque and moment of inertia, which is dynamics of rotational motion. Okay, so we've done 10 12 numericals today. We have done the moment of inertia of multiple figures. Your task is to memorize the 21 formulas and also attempt some derivations. For example, derive the expression for a cylinder, derive for a sphere. The derivation should also be on your tip for school purpose. Otherwise, those 21 formulas have to be understood and applied in numericals only. So they should be in your memory then.
ठीक है.
ठीक है जी, see you tomorrow then. Please do some revision. Help
सर
you.
कल 11 बजे कर लोगे?
यार, I have a class already fixed up, so I
सर मैं
can't change.
2 से 8 बजे तक तो मैं अवेलेबल ही नहीं
हाँ,
हूँ.
so we'll do after that, na, once you're back.
8 बजे?
हाँ, why not?
सर 8:30 में घर पहुंचूंगा.
ठीक है, तो we'll do at what? अच्छा, 8:30 you will reach.
हाँ जी.
2 से 8 because I already have a class fixed, or there's a chemistry class of that guy, and we are doing both class 11th and 12th. So I don't want to break his momentum. इतनी बार तोड़ दिया मैंने वो. I don't want to do it 7th time in a month. That's a situation I want to avoid.
सर कितने बजे करोगे?
ठीक है, तो if you're going at what time will you leave your house? Because I have a yoga class from 12 to 1, so
2
I'll be
PM.
back at my home at 2.
सर मैं 1:30 या 1 PM, 1:30 को मैं लीव करूँ.
1:30 I will enter my house because my yoga class will be complete at 1:30.
Okay.
ठीक है, you come back, let's see what happens. If you have the power, let's do a class. कोई problem नहीं है. I will check with this guy in the evening if he's okay to shift the class, क्योंकि उसकी chemistry class होती है यार.
केमिस्ट्री घर पे?
हाँ. Yes. He's under tremendous pressure because he's preparing for 2 classes and all that.
सर
Not
उनका
able to
केमिस्ट्री
handle.
प्लान लग गया कुछ को क्या?
No, मैं नहीं पढ़ाता उसको यार. I can't handle 11th and 12th simultaneously in one go. I don't have time. You can see I don't accommodate any more students also. मेरे पास अभी 7 8 10 student और हैं, but I'm not adjusting anyone. That spoils my health here. Can't sit for this long. Chalo, see you tomorrow. I will just check with him. If he is okay, I will send you a message and we can have an early class, but not at 11 in any circumstances, because I have to leave my house at 11:40. If the class happens for you, it happens at around 10.
10 ठीक है.
10 is the, or I will check if it is possible. He says 10 to 11:30 is general time. If I get up early tomorrow, we can have an early class also. I don't know what time do you get up.
सर 8 PM.
So you'll be ready by
अच्छा
8:30,
8
right?
PM नहीं, सॉरी 8 AM.
8:30 you'll be ready.
Okay.
ठीक है. So if he doesn't agree to the idea of uh, later class or an early class, I will try and do your class at 8:30 then, so that you are satisfied that you didn't miss a class, right? ठीक है. I'll send you a message. I'll let you know. If he says he's good with 10, then we will do at 10. Then you'll तब तो easy हो जाएगा बड़ा. If he's not, then we'll do at 8:30.
ठीक है.
I'll let you know. Just wait for my message. ठीक है.